Hey again. One of these guys on Facebook asked me to do a video on my tablet, and I thought I would. And let me give you kind of an example of what I got going on. But this is a Amazon Fire tablet. Just any Android one will work. And the thinking is that it's going to get data via Bluetooth, and I haven't got that all hooked up yet. But the piece of software is written in an open source tool called Processing. It's processing.org if anybody wants to go there and kind of look at it. But I think it's Java based. But it kind of feels like C++. It's kind of like they've had a baby, and it's now this thing. I don't know technically what it is, but I didn't have a problem taking my microcontroller programming information skills, knowledge base, whatever you want to call it, and applying it to this. But anyway, let me go ahead and run it, and I'll show you what it does. So this is the main display that I've come up with, going back and forth, looking at other digital dashes and all that. It kind of fabricated this, but I think I spent the most time picking out fonts and color selections that weren't, ridiculous on the eyeballs. But this is what I got. So the original idea was to have 8 thermocouples that were 4 EGTs, the front mount in, front mount out, radiator in, radiator out, and then I have 3 pressure transducers, which were fuel, oil, boost, and voltage. Or voltage would just be a line voltage for whatever your car's currently getting. And then each section, like EGT1, min, max, average, and difference, they're in like a nice little grid. So it's a 4x3 grid that I've equaled out. So all of the cells are kind of the same spot, and it's a touchscreen, so I can get into that here in a second. But I'll start with the EGTs. So the thinking is you'll have 4 EGTs for each cylinder, and then there's a min, a max, and an average of that cylinder, and then the difference is going to be EGT 2, 3, and 4, added all together, divided by 3, and then subtracted by the current EGT value, so that's the difference. So my thinking was, if one cylinder was crazy hot or crazy cold, you'd know a difference. And when it's red, it means that the temperature difference, I believe I have it set as more than 150 degrees, either hotter or colder. And again, I'm just throwing out values just to make sure that my logic works. And the values are all jumping around now. It's called perlin noise. If you look at the fuel and oil and boost, you see that quite a bit better in the voltage. It's smooth random transitions between some number and another number. And I did that just so I can look at all the values thrown across the screen. But that is kind of the situation for the EGTs. You have the difference, min, max, average, and then white text if it's normal, and then red text if it's bad. But let me go ahead and basically the section that is all the way across, when you touch it, it goes to another display. And this display has the same things, but it's just larger. On each one of the displays, you can probably tell that there's maybe you can, but like here, there's a black dot here, and then a dot there, and then a dot there. And that's the min, max, and average, and those are just black bars that float across the screen. And then I have the same thing happening, or I have something different happening with the color. So the color starts at yellow, and then when it gets further to the right, it turns red. I just thought it was, artsy-fartsy, so I was like, screw it, let's put that in there. And then when it's red, it also displays alert to let you know, hey, something's probably wrong. So that's kind of that screen. And then I have the screen, when you tap it on the left, it goes to a graph. Now, I was playing around with this a while to try to understand how this would work or how I would use it, but the thinking is, at least this is my thinking, is each cylinder has a color, and then the color is graphed, And if the typically, I think this hopefully this is the right thing to think about, but when all of the lines are on top of each other, that means, hey, everything should be working fine. But when you see one of those lines way up or way down, then you'll know that that cylinder has an issue. Figured out that was kind of neat. Put that in there, why not? But that's what I figured out, and then the graph on the left is basically just, I figured 1600 degrees, the scale. Once I actually have this in my car, I'll probably adjust the scale to something better, but I don't really know what like common EGTs are for a turbo car, or what's good or what's bad or what's just horribly bad. So when I figure that out, I'll readjust the scale and program that back in. And then to exit it, it's basically you touch down on the screen, then it goes back to the main window. So now I'll do the same thing. I'll click the front mount and front mount in. Those are both the same kind of a thing. So I'll click here, and it takes to another window. So this is a little bit different because it's using the front mount in temperature and front mount out. So my thinking of this was, I'll have a sensor on the in and the out, and then the bias in the center is kind of just mathematically the difference between in and out. So if you're stopped in traffic, the bias is going to be very low, meaning that there'll be not much difference between the in and the out of the intercooler because you're not moving. So if you're going 60 miles an hour or whatever down the street, doing a pull, or on the freeway, or in Mexico where people should be doing racing, the bias is going to be really high, meaning that there's going to be a big change between the hot air going in and the air going out. And then looking at the graphs again, I have the same lines, color combinations, text, the alerts and all that stuff. And then the bar graph in the center is kind of just the bias, just a different way of representing it. And then there's white lines there at the temperature difference, and I just kind of threw those in there. And then when you click left, it takes you to another graph. Now this is a little bit crazier, but same stuff at the top left. You have min, max, average, all that jazz. That's the label, what thing you're looking at, the in, the out, and then the bias. Same values as before, just, trying to utilize as much real estate as I possibly can on the screen, just, because I can. And then on the left-hand side of the screen, you'll see graphing, or you'll see some numbers here. So 230 all the way to 50, and then you'll see a bunch of dots. So those dots, those three dots there, and then the three dots, darker dots up top, those are the same min, max, and averages, just as a way to see the swing of things in that current period of time. And then the bottom graph is going to be your out temperature, and then the top graph is going to be your in temperature. So if things are heat soaked, those lines should be very close together. And if they're very efficient, then those lines are going to be really far apart, like 40, 45, and then 180, whatever. But anyway, so let me exit that. And then the same thing for radiator in and out. Same situation, different colors. Clicking left, different colors here, but the same scenario where 230 degrees is as hot as you want to get, and then 50 is probably pretty low too. And same setup, but the bar graph has two bar graphs now for in and out. And again, just trying to utilize ways of representing temperature and utilizing as much real estate. So I'll go back here, and then let me click on fuel. So fuel, my neighbor actually told me this idea where I took a screenshot of the background so it looks like it's kind of coming at you in front. Just big graph, big numbers, same thing. Go to left screen, same kind of a display, change the font size, same colors. I have the, as the pressure is low to high, the color changes throughout the whole thing, just, kind of winging it there. Each one of these is the same setup where, same similar thing. So a lot of the code was copied. The boost, this one was a little bit different because now I have a 30 psi to negative 15 psi pressure gauge. So I was struggling a little bit with this one to try to figure out, but what happens is, as you can see, kind of the bar graph changes. It goes from millibar to PSI, and I've seen a lot of gauges actually do that. But the min max average is there, and then I have the bar graph kind of doing this, or not the bar graph, but the graph here in the center of the screen doing the same thing where there's just a line and then moves up and down to trace your path or whatever, and that's it there. And then the volts, same kind of a thing. On here there's a volt graph. I mean, I don't know how useless that would, or useful that would be, but it's just another thing there. And that's pretty much it. So most of these ideas for colors I got from just looking at a color wheel and figuring out like what colors go good together, and I've seen a lot of like orange and blue. I didn't want to get colors that were just horribly obnoxious on the eyeballs, but when this is actually kind of in the car, because I'm going to be sending CAN messages over Bluetooth to this, I can do things like when the headlight goes on, maybe the brightness changes. So we'll see that message that says, hey, the headlights are on, dim it. There's a couple things I have to figure out still too. Is first off, well, the main thing is how to get Bluetooth data to CAN, and then having this device parse those serial strings and turn them into actual numbers. So that's going to be fun. But for the most part, I mean, most of these graphs, I just started looking online for, digital displays, and then I just kind of got some graphical ideas from them, and I just kind of started throwing stuff down there, what looks good, what looks bad, finding color combinations and all that stuff, and honestly, I kind of winged it, but, there's not a lot of people that I've spoken with in person or online that have really given me a whole lot of ideas, but I always love people's ideas, because it gets me to think about, maybe the idea is not good, but if it's not good, maybe I'll think of something else, or maybe the idea is awesome and I'll put it in there and figure that out. But I think some of the other things I'm going to be adding to this is I'd like to do something with the Haltech ECU, sending data to it and then utilizing that somehow, like error states or things like that. I know that the Morris Tech PDM when it sends out CAN messages, it'll send out like current things if something is faulted, and I can certainly build something into this where it would display like a fault status or whatever. My thinking is, the way that I have my Bluetooth transmitter to CAN, or my CAN to Bluetooth transmitter to this, I don't have it set up where this device will send messages back to the USB, the Bluetooth device, and then put messages back on the CAN network. That would be kind of cool. I don't think it'd be too difficult, but, again, something else. Anyway, kind of long video of me rambling, but, yeah, if you have any questions, throw them at me. I'd love to hear them. Thanks.